Have you ever wondered how, when you get hurt, a scab forms and eventually the wound heals? Or how a toddler gets taller and taller each year? These things happen due to an essential process called cell replication. In this process, every time a chromosome in the cell is replicated, a small piece of each end is sacrificed in the process. This is where telomeres come in. Telomeres are bits of junk DNA that are located at the ends of chromosomes and prevent chromosomal degradation. Now think of these telomeres as the aglets of your shoelaces, the protective caps that prevent the shoelace, or in this case, the chromosome, from fraying or getting ruined, thereby allowing them to replicate and not lose incredibly important genes without which the cell wouldn't function right. As a cell divides, the telomeres become shorter and shorter each time until they are gone. At this point, the chromosome cannot be replicated any longer, and the cell simply ages. Telomeres can also be considered as a biomarker for aging, as telomere length is maximum at birth and decreases progressively with age. Most cells can replicate approximately 50 times before the telomeres get too short, but oftentimes these cells escape death by making more telomerase enzyme, which prevents the telomeres from getting short. All cells in the body have the capacity to produce telomerase, but only certain cells like stem, sperm, and white blood cells actually produce it. In 2015, scientists at Johns Hopkins used research on yeast to find that telomerase is present in huge amounts in cancerous cells, allowing uncontrollable and unlimited cell growth. But while over-elongated telomeres can cause an increased risk of cancer, shortened telomeres cause DNA damage, triggering cell death and contributing to neurodegenerative conditions like Alzheimer's and Parkinson's. But imagine if we could use telomerase to immortalize human cells. We would be able to mass produce cells for transplantation, including insulin producing cells to cure diabetes and skin cells to heal severe burns and wounds. The possibilities with telomeres are simply endless.